Hey guys, good morning. I want to pick up right where we left off yesterday, and that is with question number 18. I asked you guys to do last night for homework the percentages for these, so I'll go over that real quick, and then we'll talk about how we're going to apply that to some of these numbers over here. It won't be much further step, just a little multiplication today. So for this problem, it says test scores are normally distributed with a mean of 76 and a standard deviation of 10. First of all, this picture I put here is up on the website. If you guys can't find your own, normally I'll probably pass them out during class, but you know, this is class, I guess. That is me passing them out. So, excuse me, they said, why is my pad not working? Oh no, pad can't not be working. There, okay. It's a mean of 76, right? It's a mean of 76 with a standard deviation of 10. So all we gotta do is take that 76 and add and subtract 10 from it. So going up 1, 76 plus 10, 86, 96, 106. And going down, we have 66, 56, and 46. Okay. So let's go ahead and see if we can answer these questions that they've been asking. First question says, in a group of 230 tests, how many students scored above a 96? Well, in order to answer this question, we need the percent. So we're just going to focus on finding the 3% first, and then we'll talk about how we're going to apply that to a group of 230. How many students scored above 96? So that is this up here. So again, same thing we did yesterday. We are very easily going to take this 50% up to here, right, because we know it's half and half. We're going to add 34.1%, and we're going to add the 13.6%. That will tell us how many students got up to a 96. Since they want to know how many people got above a 96, we'll just subtract that from 100. Okay, so I got my calculator, so I'm very excited about that. So we have 50 plus 34.1 plus 13.6. Okay, so if 97.7 people got up to a 96, we're going to take that number away from 100, right? So 97.7, that will give us what's left over, which is 2.3%. Okay, so let's fill that in here. What's that going to be? That's going to be 2.3%. How many students score below a 66? Below 66. So again, same thing, except we're just going to be kind of moving in from the other end. So coming in from the other end, we've got the 50% to get to 76, and then one standard deviation to get down to the 66 that they were asking about. So again, what are we going to do? We're going to say this is 50% up to here. This would be another 34.1%, and then we want to know how many is over here. Okay, or what percent is over here, sorry. So again, what are we going to do? We're going to say 50 plus 34.1, going to be 84.1, and from what we're going to do is we're going to subtract that from 100. We'll find out that's 15.9%. 15.9%. It's going to be over here. Okay, and in a group of 230 tests, how many students score within one standard deviation of the mean? When they ask that, what they mean is how many students scored in here, within one standard deviation above and below. These numbers are a little bit easier to find. Not all your tables give you these numbers, but honestly, the more you guys would do statistics, the more you would honestly, you would just know these numbers. So we're going to say 68.2%. By the way, if you get some different pictures, those decimals are rounded. Which is why I keep telling you guys not to just go ahead and add up the numbers to the left and to the right, because these numbers are rounded. They do go, I think it's 34.14. And again, we can break them down to half standard deviations. And, you know, if you do a little more advanced stuff like z-scores and things like that, which we might get into, probably not. you can take it a little bit further. Okay, so quick thing, if we wanted to find 2.3% of 230, so we want to know, we know it's 2.3%, but we need to know what that is of 230. So long story short, all we need to do is multiply. So again, you guys should know that by now, but you guys don't know. If we wanted to find, hey, what is 2.3% of 230? Okay, that's essentially what they're asking. First thing you need to do, and again, I'm going to yell at you like my 7th graders, you cannot work with percents as percents. You have to change them to decimals, okay? So the first thing you need to do is take 2.3 and divide it by 100%. So again, if we think about it, per means divide, cent is 100, right? So percent literally means divide by 100. So 2.3 per 100, but we don't have 100. We have 230. So again, all we have to do now is say, hey, what's 230? Just take whatever number they give you and multiply that times this, okay? If you guys want, again, I know a lot of you guys know the trick where you're going to move this 2 decimal points, right? Because that's when you divide by 100, that's what happens. You have 2 zeros, it moves 2 decimal points. There's 1 decimal point there, and then for this one, we'd have to move it an extra 1. So it'll be 0.023 or 0.023, okay? This will be a little bit different than when we deal with the numbers. Like I believe our next number is 15.9. Again, with 15.9, when we take 15.9 divided by 100, I'll do it. These are a little bit easier to do because you don't have to add that 0. When you move it to 2 spaces, we don't have to add the 0. It's already there. So that's 0.159 or 0.159. I found that people will try and tell me this is 23% or 0.23. It's not. It's 0.023. So again, if you guys are not comfortable with that, go ahead, take out your calculator. Nobody's watching, guys. You're at home by yourselves. Nobody's going to judge you for breaking out your calculator. 15.9 divided by 100. Okay, so first thing we need to do is divide those by 100. Okay? All right. Once we've got them divided, okay, now that we've got them in a decimal form, right? We say, hey, we're going to say, what is 0.023 times, again, I'll use the multiplication sign from here on in, but just so for this one, times 230, okay? So 0.023, 0.023, you don't need that first 0 in there, you can leave this one out. This one has to be there, this one, you have to leave that out if you want, I usually do. Times 230, and that will be 5.29. So does that number, first of all, does sound right? So 2.3% is 2 out of every 100. Well, if you got 230, you should have more than that, right? So does 5.29 sound right? Sure. Okay. So our test scores are normally distributed with a mean of 76. In a group of 230 tests, how many students scored above 96? Well, you can't have it half a student. So we're going to round to the nearest whole number. In this case, we're going to say this is 5. Okay. These are not exact sciences. These are, so what are we going to say? I'm sorry, scroll this up a little bit. So again, we're going to say, what was this? This was 0.023 times 230. And we find out that that was 5.29. So we'll say, we'll round that, we'll say about 5 students. Okay. Okay, so again, same thing here. What are we going to say? Well, we already found this one out. This is 0.159 times 230. 0.159 times 230. and that's going to be 36.5. So that'll be 36.57. So we would say about 37 students. Okay. Okay, and last one, 68.2. 68.2 divided by 100. So get that number first. 0.682. Again, if you guys are okay with just putting 0.682, that's fine. Times the 230 students, so that's 68.2% of 230. We're going to multiply that number times 230. And we're going to find out that that is about 156.86, which is about 157 students. Now, what does it all mean? Like, that's all well and good. We found these meaningless numbers about students taking test scores. Okay, now, and about you guys, about the age you guys grew up in. 76 should be, usually not in most schools, it should be your average grade, right? That's like a C, C plus, right? That a majority, so if we said these numbers that they gave us, they told you it was 76, right? 86, 96, right? And it was 66, 56, 46. Now, where I come from, right here, this is the fail, right? You know, about a little bit shade less than that. That's fail, right? That most of your students should be in here. Most of your students should be call this the D, call this the B, the C, and this the B, right? Most of your students, about 2/3 of your students should be in that DCB range, right? That sometimes you have a few more of those people that should kind of be in the A, you know, A plus range, right? And a few less of your people, these should be the F and the really F, right? Really, really F, right? So these, yeah, you should have smaller numbers of these people, right? There's got to be some sort of standard that says this. So if you've ever heard that they're grading your tests on a curve, this is what they mean. That essentially you should have numbers that work out something like this. That, you know, kind of your middle average or whatever should be 75. So what professors will do in some cases, if everybody fails the test, but some people still do better on the test, they'll grade it on what's called a curve. So what if we said that your average score for a test was a 55, right? But you got some people who got like 75, right? Well, those people should really be out here, you know? And usually this gives people the benefit of the doubt where they'll say, all right, they'll kind of keep the letter grades, but what they'll say is something like this. That essentially, you know, if you had a 55 in the middle there and they said, we're going to grade it on the curve, what they'll say is something like this. 55, 65, 75, 85, 45, 35, 25. Where it kind of shifts these numbers. Well, the professor will say, all right, well, if you got pretty much a 45 and up, you're going to pass. If you got a 45 and down, you might fail. Okay, now, again, the fairness of this, I don't know. It depends on who you guys are. For the professor, justifies them still teaching, right? Like, you know, if you're in college and everybody in your class fails, either your kids didn't try very hard, you got a box full of dummies in your students, or maybe you're not doing your job right. So a lot of teachers, and I've seen a lot of people in very fancy school districts, this is what happens, where they're going to go ahead and they're going to give out better grades to people who technically failed the test, right? So really, all these people should have failed, right? And that includes 2/3 of 68% of the people out here. We're going to say, listen, we're going to give you a pass, and we're going to work on making things better for next time. Okay? So how am I doing on time? Oh, we're 15 minutes. Okay, so real quick, I am going to go through example 19. I'm going to do yeah, I'll do the first one. You guys can take the second two. So again, the number of nails in a given length is normally distributed with a mean of 5 inches and a standard deviation of 0.03. So again, this is a common industrial application of these things, is that if you buy a box of nails, and they say they're 5-inch nails, right? That not every single one, if you put it on a really fancy ruler, really fancy measurement, not every single one is going to be exactly 5 inches. There's going to be some that are going to be a little bit more, and some that are a little bit less. How accurate do you need to be? You know, well, there's things, you know, you have an acceptable amount of error that most companies have, and if too many are above or below a certain length, then you can't sell them and make certain claims. So what are they going to say? What are we going to add? Subtract. Our standard deviation is 0.03. Okay. So what do we got? Going up. 5.03, 5.06, 5.09. Okay, so just add those numbers if you like. You can use your calculator. Okay, subtracted. What do we got? 4.97, 4.94, and 4.91. Again, would there be a few less? Yes, but we'd expect many, very short, very small number to be shorter, a very small number to be larger, 5.09. Okay, so they want to know, find the number of nails that are 4.94 inches. Find the number of nails in the bag that are less than 4.94 inches long. So 4.94 inches long. So that's going to be here. So they want to know how many are going to be less. It's supposed to be a question mark. So they want to know how many are in here. So again, what are we going to do? We're going to go 50, 34.1, 13.6, and subtract that up from 100. So what are we going to say? Say 34.1. Oops, I'm sorry. To keep this in order. 50 plus 34.1 plus 13.6. So again, 97.7 or greater, and again, just like our last problem, oops. Oh my God. 100 minus that number will give us what's left over, which is going to be 2.3% that we saw in the last problem. So 2.3%. So what is that? 0.023. Again, if you guys forgot that number, we're going to say 2.3 divided by 100. We want to know, hey, was that times this 120? So that number times 120 is going to give us about 2.76. So 2.76, or about 3 nails. Okay. And what you have to do as a company, you have to decide, is that acceptable? That 3 nails in this box are less than that, or people not be able to use them. I mean, it is 120 nails. You know, if you've got 117 good ones and 3 bad ones, probably not the end of the world. Okay. But anyway, so if you guys can give B and C a try, again, find the percent, turn the percent to a decimal, multiply it by 120, and then just round to an appropriate number. Okay, round to the nearest integer. Okay. So good luck. I hope these are helping you guys, and I will talk to you guys tomorrow.